This is the second video on Chapter 24, Linear Transformations. We're going to look at example 300. Now recall from example 299 that this function we have defined from R3 into R2, t of x, y, z is 2x minus y for your first component, and 2y plus z is the second component. This is a linear transformation. We proved that in the last video. That's what part 1 was about. Now, theorem 299 tells us that any linear transformation from Rn into Rm is matrix multiplication. And so we have a linear transformation from R3 into R2. According to theorem 299, this is matrix. We can define this in terms of matrix multiplication. So what we want to do is we want to find A such that our linear transformation T is T sub A, which just means we're going to multiply this vector on the left by A. We're going to use the proof of theorem 299 as a guide. So we're going to look at our function values of our basis elements from R3. So T of I, T of J, T of K. And so all we do is we apply our function to 1, 0, 0. We get 2, 0. We apply our function to 0, 1, 0. And we have the vector negative 1, 3. Then finally we apply our function to 0, 0, 1. And we have the vector 0, 1. And so we set A equal to this matrix. Notice how we got that. We made these vectors the columns. So 2, 0, negative 1, 3, 0, 1. So that is fairly simple. Now let's check to make sure that it's correct. So we'll take a vector in R3 and we'll apply T sub A to that vector. So that just means we're going to multiply on the left by the matrix. So we take our matrix, multiply by the vector x, y, z. Do the matrix multiplication, we end up with 2x minus y plus 0, and then 0 plus 3y plus z. So this is the vector we get, and we notice that this is in fact t of x, y, z. Note 301 tells us that we can generalize this. So it's not quite as nice, but anytime you have a linear transformation from a vector space into another vector space, you can define a matrix and use that matrix to help you understand the linear transformation. Not quite as nice as theorem 299, but we still get to use matrix multiplication to understand a linear transformation. This morning I did example 302 in class, and so I'm not going to make a YouTube video for example 302. So I want you to see the Collaborate recording from 4/27/2020. So this example is worked out in that video.